So, what is evolution? And can we evolve? Can I evolve? Can you evolve as individuals, or only populations evolve? And did all life on Earth look the same all the time through its geological eras? Or even our thought about life, biodiversity, or life on Earth was the same throughout human history? Did we think about where all these species came from, or how exactly did we get to what we know about evolution today? So it turns out that people were thinking about biodiversity or life on Earth for a very long time. So from what writings we still have, we know that Greeks were already far ahead than others, starting with Anaximander, who realized that might be some connection in between fish-like forms and animals living on land. Or later on, Empedocles considered organisms or animals that are half animal, half man, or half human. And that wasn't very unusual for the time. Mythology and folklore and even fairy tales tell us about lots of animals such as centaurians, or chimeras, or other animals or other creatures that can be part human, part animal, or different parts of different animals in different location. So that was considered before. But maybe one of the first naturalists that actually thought scientifically about the natural world and how there is maybe a continuum from lifeless form through to plants and animals that are easily differentiated between each other very early on. And so after Aristotle, future naturalists based their ideas on his concepts and writings. So fast forward. First of all, do you need to remember the names of Anaximander and Empedocles and Aristotle? I believe all of you know Aristotle at least a little bit. I just want you to be curious and look things up and read. But no, I will not test you in what exactly did Anaximander think versus what Empedocles or versus what Aristotle thought about the evolution of species on Earth. So we're moving fast forward all the way to the 18th century, and we'll meet Linnaeus, Carolus Linnaeus, who turns out was a Swedish physician who needed to make concoctions for his patients. So at the time, a physician needed to know what plants do you need to make a particular formula to treat your patients. So Carolus Linnaeus realized that it's very difficult to remember a whole paragraph scientific name for each species of the plants and some animals and some fungi that he needed to create these concoctions to treat his patients. So he was a biologist, he was a botanist, and he's known mainly for being one of the best to classify organisms. And basically, the most important aspect of his fast forward thinking was by introducing the binomial system of nomenclature or naming organisms. So instead of having a whole paragraph for each species that it's more or less as a description in Latin, no less, for each species, he reduced that paragraph to only two names, just very similar how we have a first name and a family name. Unfortunately, from an evolutionary perspective, Linnaeus considered that all species were the same on Earth from the beginning, and they cannot change from one to another. But very soon after, so still in the 18th century, a Frenchman, biologist and zoologist, Jean-Baptiste Lamarck, came up with the idea of evolutionary descent, which at the time was coined or labeled Lamarckism. So early 19th century, Lamarck publishes his theory of evolutionary descent. And he is very right in a lot of aspects of his theory of evolution. So he does agree that there is change through time instead of just fixicity of species, as Linnaeus thought. He also considered that maybe all life evolved from very simpler forms of life, unicellular. And then the idea of change is pushed by environmental change. So you adapt or die. And he uses this idea of what you don't use, you lose, and what you need, it will improve and you gain. So even though he's very far ahead in his concepts of evolutionary descent and evolutionary theory, Lamarckism has a major flaw. And he considers that you can acquire, you can inherit what you acquired, what characteristics, what traits you have acquired through your lifetime. So, for example, if your parents are Olympic swimmers, that means they probably have an enlarged heart and they have great muscles and a very balanced body shape that allows them to be very fast, great lung capacity. So all those were acquired through their athletic activities. But that doesn't mean that their offsprings automatically will inherit those characteristics. So now we know that somatic characteristics that were gained through your life. So let's say, for example, you tan because you just enjoy being in the sun more than others. That doesn't mean that your offsprings will acquire that, will inherit those characteristics. So through time, naturalists accumulated more and more knowledge and compare life on Earth through a variety of biological and natural life sciences. So these areas of knowledge were considered through the perspective of biogeography, or what species are found in which, on what continent, and how are they connected to each other, or are they connected to each other? Did they evolve from the same descent, or did they adapt to a similar habitat? So people looked at the shapes of different organisms on Earth, both plants and animals and so on. So both shapes, morphology, or even anatomy. And naturalists also looked at rocks, and they noticed that rocks around the Earth could be similar depending on what depth do you dig. And speaking about digging, when you dig, sometimes you find fossils. And fossils are just preserved previous life in different layers of rocks. So we'll go to each of one of these concepts and areas of natural world explorations that have accumulated the knowledge that we have today and gave us the perspective that we have about evolution.